Welcome to Statistics. My name is Dr. Twane. In the next few minutes, you'll be able to derive the Pearson product moment correlation formula. So we are going to do that in 4 simple steps. And that is 1. We know that R is equal to summation of x, y all over the square root of summation of x square, summation of y square. Where our x, which is small x, is equal to x minus x bar, and our small y is equal to capital Y minus capital Y bar. Now, these are the 4 steps we are going to use. Let's say that the whole of this will be our step 1. The whole of this will be step 2. And then this will be our step 3. While step 4 will be substituting what we have obtained from 1, 2, and 3 in this formula. Okay, now, from 1, where we have summation of x, y, then that's going to be equal to summation of, now our x from what we are told here is capital X minus capital X bar. Now, our summation of y from what we are given here, our y is what? Y minus Y bar. And if that's the case, then it will imply that we have summation of, we are going to take this to multiply the whole of this, and then we'll also use this to multiply the whole of this, so that we'll have x into y minus Y bar, that's this time all of this, and then we have minus x bar, which is this, into the whole of this, which is y minus Y bar. Okay, so this will mean that our summation of x times y will be xy minus x times Y bar will be xy bar minus x bar times y will be x bar y, and then minus times minus will be plus, so that our x bar times Y bar will be x bar Y bar. Okay, now to open the bracket, then we'll have multiplying this or opening this bracket, we'll have summation of x, y minus. Now, remember that our Y bar is one particular value, while x is a series. By that I mean we have values for x and values for y. So the values of x are like this, a series, and that of y are also different values like this. But the summation of x all over n will be summing all these values and dividing by n will give us our x bar, so which is one particular value. And for that reason, we are going to say that we have Y bar summation x minus, the same thing is applicable here, so we have x bar summation y plus, now when we want to sum x bar Y bar, we are not going to use summation because we are looking at one particular value, so it will be better to say how many times this particular value occur. So we will have n, which is the number of times the value occur, x bar, and then Y bar. So that will mean that we'll have summation of xy minus, now we know that Y bar is summation of y all over n, and this summation of x is this, summation of x, minus x bar is summation of x over n, then this summation of y is this, summation of y plus our n. X bar is summation of x over n, and y bar is summation of y all over n. And so this n will cancel this n. Then we'll be left with, here we have summation of xy minus, now this is summation of y, summation of x. For just convenience sake, I want to put the x before y. Of course, we know a times b is the same thing as b times a, so it doesn't matter which comes first. So we'll have summation of x, summation of y all over n minus, this is also summation of x, summation of y all over n plus, this already cancelled this, so we have summation of x, summation of y all over n. So this is like the additive inverse of this. So if you are subtracting, this will cancel this. So if that happens, we'll be left with, we'll have summation of xy minus summation of x, summation of y all over n. And so if we are to take the LCM, we can, this is okay. We are going to make use of this somewhere. But to take the LCM of this will be equal to, if we take the LCM, then LCM will be n. And we'll have here the same thing as over 1. So it will be 1 will go into n. We'll have n summation xy. That's the n multiplying the numerator. Minus n will go into n, 1 times this. We'll have summation x, summation y. So which means that, remember what we have here. Remember that what we have here is summation of xy. So our summation of small x, small y is equal to n summation capital X, capital Y minus summation capital X, summation capital Y all over n. So we have been able to derive the numerator, which is the first one. Now, let's consider the second one, which is part of the denominator. Now, what we have there is, there we have summation of x squared. And our summation of x squared will be equal to, this will be equal to, now we'll have summation. Remember, we are told that our x is x minus x bar square. So, which will be the same thing as saying summation of, we have x minus x bar. Since it's square, it means it's multiplying by itself. So it will be times x minus x bar. So now doing the same thing we did earlier, then it will be equal to, now this will multiply the whole of this, and this will also multiply the whole of this, so that we'll have summation of x into all of this, which is x minus x bar, and then we have minus x bar, which is this, into now x minus x bar. So that will be equal to summation of x times x will be x squared minus x times x bar will be x bar minus, here x bar times x will be x bar x, and then minus times minus will be plus, so we'll have x bar x bar. Now there won't be anything wrong if we say x bar square, but for convenience and what we want to do, we will just leave it as a x bar x bar. So this will be equal to, now let's open the bracket. So if we do that, we'll have, now summation times this will be summation x squared minus, we'll have x bar summation x minus, that's this, the same thing, x bar summation x, that's multiplying this, and then the last one will be plus, just like what we did earlier. We'll have n x bar x bar, and so this will be equal to summation of x squared minus, and we know that x bar is sum of x over n, and then this other one is a sum of x minus some x bar is again is sum of x all over n, and this is a sum of x plus n. X bar is sum of x over n, and this other x bar again is sum of x all over n. Okay, so this n can cancel this n. And now when that happens, we'll be left with what? Summation of x squared minus summation x all over n. And this will be minus summation x all over n. And then this will be plus summation x all over n. Now we can see that this is additive inverse of this. So it can cancel out. So this will cancel this. And we'll be left with summation of x squared minus summation x all over n. Now, if we do the same thing we did earlier, then just like what we did here, we are going to make use of this somewhere. But for now, let's break this down a little. So that if we are taking the LCM of this, remember that this is the same thing as over 1. So LCM will be n. 1 into n will be n times the numerator, which is summation x squared. This minus is this. N will go into n, 1. 1 times the numerator will have summation x. So the implication of that is that that implies that our summation of x squared is equal to, we have n summation x squared minus summation x all over n. So, which means that this is a solution to this particular component of the numerator. So we'll have this now. We also have this as solution to. We also have this as solution to the numerator. Also, for our summation of y squared. Now, I want to give you the opportunity of trying this out by yourself. So the same thing we did for summation x squared is what I want you to do for summation y squared. And if you do that, you'll see that our summation y squared will be equal to n summation y squared minus summation y all over n. So now the next thing is to substitute what we have obtained, which is this, and this in what we had initially, to substitute them here. And if we do that, we'll see that will be equal to, in fact, repeating what we have there, is summation of xy all over the square root of summation of x squared, summation of y squared. So that will be equal to, now what we have here is this. So which will mean n summation xy minus summation x summation y all over n. That's the numerator. Divide by. Now the denominator is the square root of. So this component is this, which is n summation x squared minus summation x, which you can just write as summation x squared, because summation x and summation x is summation x all square, all over n. Then the second part of it, of the formula, which is this one, is what we obtain here, which is what? N summation y squared minus summation y all square all over n. Okay, so if that is the case, then it will mean that this is n summation xy minus summation x summation y all over n divided by the square root of, now we have n summation x square, that n summation x square minus summation x all square. And then this is also n summation y square minus summation y all square. We'll have, this time this is n square, so that we'll have this, so that this will be equal to, now n summation xy minus, this is summation x summation y all over n divide by, so this is n summation x square minus summation x all square, and then we also n summation y square minus summation y all square all over. Now if we take the square root of this will be n, and then we maintain this other square root here. So this is this, but we are taking the square root of this to be n. So the next thing to do will be this is n summation xy minus summation x summation y all over n. We'll change this to times, and the numerator will now be, the denominator will now be the numerator, such that we'll have n all over the square root of n summation x square minus summation x all square. And then again we have n summation y square minus summation y all square, which is the same thing as what we have here. So because it's product, this can cancel this, so that our arrow will be equal to, what we have as numerator is n summation x y minus summation x summation y all over. Now what we have as denominator is square root of n summation x square minus summation x all square. And again we have n summation y square minus summation y all square. And that becomes the Pearson product moment correlation formula, what we call the direct method. If you have any queries, if you have any question, feel free to hit the comment section. If there's any problem you want us to solve, feel free to go to the comment section, like the video, subscribe to our channel, so that we can always, you'll be notified whenever we bring out new videos. Thank you, and God bless you.